Good morning. My name is Ian Harrison and I'm a Strategic Military Advisor for QinetiQ. Many thanks for taking the time to listen to this presentation on deploying prototype warfare. We produced a report about it in 2018 and since then have been working with others to evolve the concept and help operationalize it. If you're interested, our report is available online. Today I aim to cover the what, why and how of prototype warfare before handing over to Brendan Nolan, who will look at its application in the air domain. The term prototype warfare might not feel particularly new or revelationary to many of you. At the very least, the underlying idea will be intuitive. My interest in thinking about it was sparked by reflecting on some key articles I read 3 or 4 years ago. In particular, the work of the US Army's Mad Scientist Lab and War on the Rocks site highlighted the challenges facing military forces in fast-tracking technologies and capabilities to warfighters in a meaningful timescale, whilst also understanding their impact on the way that they were to operate, train and be organised. Throughout, they offered views on the high-level change needed, such as full-scale acquisition reform and strategic culture change, with which I don't disagree, but frankly, good luck with that. I felt the one thing they missed was offering any practical steps that can be taken right now to solve some of these issues. So our contribution to this debate was a more practical report which sought to advocate the value of an approach like prototype warfare, identify potential barriers to adopting it, and offered ways to overcome them in the modern military context. History has many examples of where early-stage technology or equipment is rushed into service with the intention of giving the user an operational advantage. In the air domain, early use of air power in the First World War and some of the technologies applied to the aerial defence of London during the Second World War and the Dam Busters raid provide some good examples of what I might call prototype warfare. Notwithstanding these, there's often a strong temptation to link the notion of prototype warfare solely to technology. And whilst I later advocate the need for a technology focused in the current era, I would highlight its relevance to operating concepts, such as air-land battle in the 1980s. This concept exploited existing capabilities like the A-10 and spawned new ones like MLRS and the attack helicopter. The examples in this slide, even the more strategic ones, highlight innovation as a dominant theme, perhaps in part because necessity becomes the mother of invention, or maybe this is just my after-the-fact rationalization. So what's the nub of our thinking about prototype warfare? As much a mindset as a strategy, we see it as the willingness to take calculated risk with capabilities not usually considered ready for operational use. If you like, experimentation in contact or battle in beta. We posit that prototype warfare is a mentality which links technology horizon scanning with innovation and experimentation, including its use in operational theatres. It's principally about determining the value of early-stage technology for operating concepts and capability, and then being able to adopt it faster than the other guy. It is emphatically not about playing fast and loose with safety and security, but recognizes that operating risk profiles and practices can be changed. So, it can provide capabilities for immediate adoption and subsequent evolution, inform force development, and help de-risk, reduce cost, and accelerate more traditional approaches to procurement. I'm sure today's audience will instinctively understand the rationale and benefits of adopting an approach like prototype warfare. The pace of technological change continues to accelerate, and we're still grappling with how best to seize and exploit its opportunities. Armed forces that want a competitive advantage can't afford to wait until technology is mature before adopting it. They need to embrace it early and determine and shape its utility, and do so more quickly than adversaries. Because even if we're not prepared to embrace this pace of change, others are willing to do so, with several well-documented examples of prototype equipment being used in operations, albeit with mixed success, but frankly they are still learning from it. Perhaps on a more positive note, using prototype capabilities provides an opportunity for you to unsettle and sow doubt in the minds of adversaries, thereby contributing to information advantage and modern deterrence. So the real test of your understanding of prototype warfare might be your reaction to this image. When I look at it, I don't think drone or aircraft. I contemplate what advantage can be achieved by combining the human-machine team and its impact on doctrine and capability both now and in the future. Robotics and autonomous systems are a great example of disruptive technology. Repositioning the human's role and purpose in the battle space, and handing over tasks and portions of decisions to complex systems of software, control architectures, and physical platforms involves a very different approach to business. This means that identifying the value of a new technology or concept can take time and several iterations. However, we have found that simply using technologies to perform business as usual, albeit in slightly different ways, tends not to offer the transformative leaps in capability. The genuine light bulb moments have happened when users have taken technologies and initial concepts as starting points, then refined them through experimentation. This on-the-hoof innovation often results in a range of operational benefits and opportunities which can lead to a reimagining of tactics and other operating norms. So you see that prototype warfare can create a virtuous cycle between technology and concepts, where one informs the other and so on. Unlocking the imagination needed to enable this and to see what could be requires creative thinking, and, in my view, this is most likely sparked by a question. So we should be encouraging our people to ask questions like the ones you see here. Military personnel need to be inquisitive, be aware of what technology is out there, and how it can be harnessed for military purpose. By way of caveat, however, I am most certainly not advocating a weapons-free zone for all manner of techno-geekery. There's no shortage of people out there who will try to offer their unique sort of wacky idea. The armed forces need to be quite discerning about what they try, as time and other resources are finite. The benchmark is likely to be based around 3 questions. What problem will it solve? How do we plan to use it, initially at least, and will it work safely? There's a temptation to see prototype warfare solely as a focus on the visually attractive parts of new capability, for example, drones at air shows, and ignore the huge volume of less visible but essential engineering, safety and assurance activity that is required. Prototype warfare can't just be about piling technological novelty into exciting use cases. It also needs to help identify the merits of candidate technologies before embarking on full development life cycles. But development life cycles don't disappear, and the cost of ignoring hard realities can throw plans into chaos further down the line. The flip side of this, of course, is that military personnel can become disillusioned if they see something experimental that they like and value, but don't get their hands on it in a tangible time frame. With its aim of trying to offer practical solutions to real problems, our report focused on 7 barriers to adoption of the notion of prototype warfare and suggested mitigations for each of them. While time prevents me from going into each in detail, they fall broadly into 2 categories: cultural perceptions and practical. The former speaks as much to the inherent conservatism in some parts of the armed forces, and the latter usually provides perfect excuses to blame others, often characterized as faceless bureaucrats, when in reality effective and early engagement in both areas can mitigate problems. So let's look at institutional challenges and then how we might navigate to successful exploitation of prototype warfare. First, despite evident enthusiasm, armed forces can easily become overwhelmed by too many ideas, good or otherwise. This problem is compounded when resources, be it money, people or time, are tight. and it often becomes easier to say no or to defer experimental decisions. In a democratized world of technology, frustrations are exacerbated by the inverted age pyramid of older decision makers demanding significant evidence from digital native users to make relatively modest progress. It's also been telling to listen to some concerns raised about technology's profit in the prototype warfare debate, which frankly are thin veils for tribal or branch existential concerns. Notwithstanding all this, it is good to see a growing appetite for innovation, experimentation, and exploration of prototype capabilities in the armed forces. This will undoubtedly help change the culture and shape alternative views about future capability. Secondly, the boundaries between the various elements of capability and acquisition system reinforce linear thinking and transactional behaviors. Prototype warfare requires a much more fluid flow of ideas back and forth across the defense operating model, with innovative empowered sponsors for new ideas. Integrated teams working on small portfolios of projects with challenging near-term objectives will help drive rapid fielding and spiral evolution of capability, and ultimately reduce costs. However, it is unrealistic and unnecessary for all procurement to adopt these methodologies, and the armed forces might consider a bimodal approach, with Mode 1 being used for large-scale platform procurement, which is undoubtedly likely to be slower, and Mode 2 being used for agile technology-based capability with a more rapid cycle. Thirdly, defense has a skills and experience deficit in managing and delivering complex innovation and experimentation, and this is exacerbated by a lack of continuity in posts, which affects both the military and, frankly, only marginally less so the civil service. Too often, a great public sector delusion that it can do everything itself denies defense the opportunity to work routinely and collaboratively with some very able and ultimately probably better value capability in the commercial sector. And finally, the public sector lacks agility in moving resources quickly to new projects, and there remains an underlying fear of failure when experimenting with novel or prototype capabilities using public funds. This is the antithesis of innovation. Arguably, the armed forces are only really constrained in their ability to deploy prototype capabilities by imagination. Implicit throughout this presentation is the idea that prototype warfare can and should apply to operational deployments. This will require some innovative thinking and may need some deployed industry support, but could in itself contribute to achievement of operational effect. Arguably, the key outcome of prototype warfare is effective exploitation of the evidence it generates. This requires deliberate and organized plans to generate, gather, and analyze lessons from experimentation. The growth in synthetics technology offers very clear opportunities to experiment virtually with prototype capabilities. Multiplayer interaction against realistic threats and in realistic environments will help shape operating concepts and the next spirals of capability development. Increasing use of digital models or digital twins in the design of complex platform and subsystems will also enable the exploration of their key characteristics in the lab before exposing them to virtual wargaming and live experimentation. Last, safety and security has been a constant thread throughout this presentation. It is too easy to take counsel of fears and be persuaded that fielding prototype capabilities is too difficult or too risky. In all the discussions we've had with those regulating these areas, they firmly believe that our prototype warfare hypothesis is both credible and achievable. Their perfectly reasonable request was to be engaged in the very earliest stages of thinking, rather than being presented with a fait accompli later in the day. They also felt that when equipped with better contextual information, commanders would be happy to take greater risks. I'd like to wrap up by offering a few thoughts on the key ingredients to embracing the potential of prototype warfare successfully. First, embraced technology horizon scanning. And whilst this needs to be done institutionally, it also requires a certain personal inquisitiveness too. It also helps to be able to imagine how emerging technologies can provide operational advantage, or existing technologies could be adapted. And it's worth tracking how adversaries plan to use these technologies as well. Next, nurturing an experimental mindset across the force takes effort, example, and leadership. Making the point that it's okay to fail, so long as you learn from it, is fundamental. The whole force needs to see every activity as an opportunity to try new things, albeit this implies underlying competence in core skills. Third, some key enablers will need to be established and sustained. Taking an enterprise approach to the individual aspects of prototype warfare within an understood architecture is essential to ensure effective capability coherence and integration. It's not good enough just to have and/or gather ideas. Commercial models need to be sufficiently agile, flexible, and innovative to enable exploitation of any experimentation. All of this requires an inclusive culture of engagement across a wide range of military, civilian, and industry stakeholders. Finally, and notwithstanding my earlier comments about the deficit of skills and experience, there is a significantly large wider team that can be harnessed within and by defence to help deliver prototype warfare. Undoubtedly uncomfortable for all parties on occasions, the nature and composition of these teams drives diversity of thought and far greater innovation. Closing the gap between user and engineer or scientist is key to accelerating development of technology and optimizing it for military use. Fundamental to the success of these teams are the right collaborative behaviours, like was achieved in support of the raids on the German dams in the Second World War, or bombing Port Stanley Airfield in the Falklands War. I'll hand over now to Brendan, who will explore the notion of prototype warfare in the air domain.
Thanks, Ian, for setting the scene and discussing the concepts of prototype warfare. The challenge for QinetiQ, and I'm sure all of us associated with the generation and delivery of air power, is how can we put the theory into practice? How can we as a community embrace prototype warfare in the air domain? This is definitely a challenge, as I cannot think of many examples in history where the philosophy that Ian has explained has been usefully deployed. Perhaps the clearest example dates back to 1943 with Operation Chastise, better known as the Dams Raid. The objective was to breach a number of dams in order to disrupt the German ability to manufacture weapons. The initial analysis concluded the RAF would need to drop an enormous bomb from altitude, and calculations determined that the bomb would need to be 10 tons and drop from an altitude of some 40,000 feet. No bomber aircraft was capable of flying at such an altitude or carrying such a heavy bomb, and so a different approach was needed. A much smaller explosive charge could work if exploded underwater against the dam wall, but the German dams were protected by torpedo nets, rendering this concept useless. A new prototype bomb was designed in the shape of a cylinder, designed to be given a backward spin. If dropped at precisely 60 feet and 240 miles per hour at a predetermined release point, the bomb would skip across the surface of the water before hitting the dam wall. The backspin would cause the bomb to submerge, running it down the side of the dam towards its base before detonating. Remarkable blue sky thinking. Testing of the concept required the building of a scale model to test the theory of bouncing the bomb. This was done at a specially built prototype facility, which allowed for repeated low-cost trials until the concept was proven. The next phase was to see if the explosion would be effective, and this trial was carried out on a real dam in Wales. The first flight trials were in the following January, and the mission flown in May, only a year after the initial idea. Every aspect of the mission was rapidly prototyped: the weapon, delivery, method, aircraft modification, and of course the tactics, techniques and procedures needed to deliver that weapon. All of the barriers and issues described by Ian were overcome, I guess due to the operational imperative, necessity being the mother of invention. My next two examples are from the 1983 Falklands conflict and the First Gulf War in 1991. I look forward to discussing it with you in the Q&A if you think that these are really examples of prototype warfare, or if they're just rapid deployment of capability. The invasion of the Falkland Islands in 1982 necessitated the addition of an in-flight refueling capability to the Nimrod to allow it freedom of action to operate in the South Atlantic. 8 aircraft were fitted with in-flight refueling probes taken from Vulcan bombers in the space of just 18 days. Also, the previously unused underwing hardpoints were adapted to carry Sidewinder missiles for self-protection. Both of these modifications used existing hardware, so whilst the ability to rapidly design and certify the installation was impressive, was this truly prototype warfare, or just rapid capability insertion? And does it matter? Arguably the end state was the same. The 1990 Iraqi invasion of Kuwait saw the tiled pod, which had been in development for around 2 years, rushed into service in just 46 days. During the air war itself, 2 of these pre-production tiled pods were used effectively throughout the campaign. Again, it could be argued that the Gulf War just provided the operational pull to accelerate the programme, which had been underway since 1988. But there's no doubt that the deployment necessitated rapid development of the tactics, techniques and procedures which provided the basis of LGB operations for years to come. Perhaps the most agile and recent examples of prototype warfare in the air domain come from non-state actors operating unmanned systems. There are examples from all around the world of terrorist organisations deploying drones to their advantage, with missions including surveillance, delivery of explosives, and for remote detonation of IEDs. Often users have simply bought off-the-shelf COTS equipment, which has been adapted to suit their missions. And often modifications are made locally to adapt the drones, and I've no doubt that mistakes were made and lessons learned in iterative loops until the air systems were effective. Surely these operations capture the essence of prototype air warfare. Unencumbered by doctrine or formal systems and with limited budgets, the operators have developed their systems on live missions, adapting each time to better their results and to survive. They almost certainly do not suffer from the institutional challenges faced by most developed nations. So the challenge facing most of us today is how do we create the environment that allows the development of rapid prototyping for military effect? Ian spoke about the institutional challenges we face: user inertia or suspicion, disjointed capability management, problems with skills, experience and continuity, agility of resourcing, and fear of financial failure. And also the barriers, which included safety, security, regulations, and the existing procurement systems. As highlighted by this slide, the USA, UK and others have created rapid capability offices, which are certainly helping tackle the issue. Great progress has been made by these organisations in overcoming many of the issues that Ian highlighted, and I hope they continue to develop and flourish. But I'd be interested in your views on how do we collectively move forward? Do we in industry need to develop better commercial relationships with our competitors? How can the military steer companies to invest in the right areas without compromising security? Especially when so much innovation comes from small, agile companies that may not have the usual security accreditations of big companies like QinetiQ. And how does any company ensure a return on shareholder investment when the path is not laid out clearly as per a normal procurement? What part does big government play in setting of industrial policies and balancing the desire for sovereign capability over value for money and price? There are many questions which we could and should pose to test our thinking and challenge the status quo. In summary, Ian has laid out the principles of prototype warfare and explained the theory and given some interesting examples. I've tried to highlight some historical case studies as well as highlighting how non-state actors, unencumbered by process, are beginning to exploit the air domain. And finally, I've tried to pose some of the difficult questions that we in industry, and I'm sure our partners in the various rapid capability offices, are trying to answer. Ian and I would be delighted to engage with you for further on this subject. will both be now available for an online Q&A session, or do feel free to contact us after the event. Thank you for your time, and I look forward to the Q&A.